I think we're live. Um, Hello, everyone. It's another app architecture Q&A. I lost count. I don't know if anybody remembers which number we are. Matt and Florian
It's
are also
number
here.
12. Number 12. Hi, everybody.
Hi, Matt.
Hello from Australia. I didn't realize we'd done that many. There you go.
Okay, so let's dive into the questions. The first question is by Yaran, and he asks, well, it's a long question, so I'll try to summarize as accurately as possible. There's this thing where if you have, let's say, a navigation controller, if you would do something like MVVM and really push it through and even control your navigation controller through MVVM, then where is the source of truth? So let's say you take your view model and from that you derive what you want to show in your navigation controller. Then you have the problem that all of a sudden navigation controller starts doing things independently of the view model. So like it pops the view controller, and now your view model isn't the single source of truth anymore. And how do you deal with this? And is there any advice for working with this? So I don't know, Florian, what do you think about this?
Well, that's definitely something you run into in many places in UIKit, with UI navigation controller being one of the prime examples, that these components just manage their own state. And sometimes they give you the option to decide if you want a certain state change to happen, and sometimes they don't, like the back action in the navigation controller. And so we run into this issue also in the book, in especially in architectures like the Elm architecture or model adapter view binder, that try to push this to the extreme and really just have basically have an abstract representation of the current view state and then just derive the views from there. And we write a little bit about this there. In our example, we don't have this problem in the MVVMC implementation because we don't try to push it that far there. So in our MVVMC implementation, the view model is the source of truth for some views or for some properties of some views. It doesn't try to derive all views from the view models. So, for example, we have the coordinator there, and the coordinator is responsible for making changes to the navigation stack. And there we don't try to drive the navigation stack from a view model. So if the user hits the back button, the other screen will come up again, and the coordinator doesn't even know about that, because in our example, we don't need to know about that. So we don't run into this problem there. But you definitely could if you would try to track the navigation state there as well, or to drive it even through a reactive binding, for example. Yeah, but
Matt,
Matt,
do you have any
have
thoughts
you?
on this?
Yeah, like Florian was saying, yeah, if you had built a reactive coordinator where you wanted to bind the coordinator to your navigation controller, it would be a harder problem, but it's not impossible. You can listen to the will show and did show notifications on the navigation controller's delegate, and from that you can guess what has happened. You need to be a little bit careful, but it can be extracted. But there's a separate question of how do you deal with views that don't want to um, respond to state all the time. They want to drive their own state and not necessarily share that. And the answer is you can't really deal with it. Unfortunately, if the information is fully hidden, then you don't have access to it. It's just there are always going to be classes that were written for older kinds of MVC where view state was the business of views, and views weren't expected to share that. And um, sometimes you're going to need to write your own views instead of relying on those kinds of older classes.
Yeah. The next question is by Dmitry, and he asks, how do you deal with features that need to be shared among multiple parts of your app? So, for example, adding support for adding favorites to a photo app, and you want to use this favorite feature in multiple places within your app. And yeah, he asks, how do you do that? So Matt, do you have any ideas on this?
Yeah, I mean, the answer is quite simple. You put it in your model. The model is the thing that is observed from multiple places, and the model should not be tied to a given view. So if you want to put a favorites feature in your app, then have a separate part of your app that represents this, this state. This represents, he was talking about photos in the question. So you have a model which represents all of your photos. It doesn't necessarily have to store all the photo data, but you at least represent the identifiers of each photo. And when you want to change the favorite status, you mark favorite against that identifier. And if it has to communicate with a server, he mentioned the API, and maybe you don't want to wait for API communication with the server, well, then, the model can deal with that, and the model can handle the communication to the server and possible rejections and errors from the server, so that the view can just pretend as though it has set it and it can move on.
So there are two more questions then. Well, when you say the model can deal with that, you're not necessarily meaning the model objects, because it would be the model layer making network requests, but it doesn't necessarily need to be your model object. So that's something to keep in mind. And the other question is, how do you then deal with things that are not in the model layer? Like if you need to reuse the same UI for adding these things, what do you do about that?
Well, creating a reusable view is its own kind of problem, but that's what you need to look at. You need to look at a view that you can construct in multiple places. So when you present the folder full screen over here, having a reusable view that will happily sit for that full screen view of the folder versus in the listing. Or, simply don't have a reusable UI if you can't make the one view work well in two places. Just have independent views that rely on the same data. They're driven by the same data. And to an extent, most of the logic can be in the data, in the abstract version, and then the view is just, putting an icon on screen.
Florian, do you have any additional thoughts on this?
Well, I would just say on a meta level, I think it's really important that you consistently implement what Apple also calls the observer pattern if you display the same things in many different forms and many different places in your app. So let's say you have this Photos app and you display photos in all kinds of different ways, and they all should be, and you could favorite them or unfavorite them. And I think it's, if you implement this consistently, so that all the changes to the favorite status, for example, go through your model, and all your views, or view controllers for that matter, observe the model consistently, then you will have a much easier time to get this right. And everything that's left in terms of UI, well, that's just what Matt mentioned in the end. So it's a matter of pulling out a reusable UI component. But all of that should be based on a consistent implementation of the observer pattern to make your life easier.
Yes. The next question is about Facebook's architecture. Well, I guess one of their many architectures. Taron is asking about components. So Facebook has a talk where they talk about components, and I think there are even multiple component-based architectures that they have or had in the past. And the question is, have we seen this components architecture? How does it relate to MVC plus view state, and how does it relate in general to what we discuss in the book? I've never worked with Facebook's component architecture, so I'm a bad person to answer this, but Matt, maybe you have some ideas about it?
I mean, all I've done is a little bit of React Native programming, but in general, component-based architectures are more about the idea of each view maintaining its own separate data pipeline, or at least building it as though it maintains its own separate data pipeline, so that you have each tiny little section of your screen fetching its own network data and not getting in the way of other sections on your screen that are fetching their own data. Facebook choose to implement this with little components, which are like, they're almost like self-contained view controllers living within the overall screen, or you could really just think about them as very full-featured views. It's up to you if you want to go that way. I'm not sure it works particularly well with UIKit. Although Facebook did originally invent it to work well with components, collection views. The Facebook implemented Component Kit for managing collection views. You can have a look at what they've done. It's really, most of that work, though, is about maintaining a data pipeline. But ultimately, when they implement React Native, you often end up having a Flux or Redux store at the back end. So it can end up working data-wise a lot like the Elm architecture, where even though you've got all of these views that might make their own requests, they might, send their own messages to the server just integrates it into the common store, and the store just re-renders all the views. Yes, you can write the logic for each component separately, but ultimately, you're still putting it on just a single consistent data pipeline.
Makes a lot of sense, yeah. So we have one final question by an anonymous person, and they're asking, well, it's again a very long question, so I'll try to distill. Well, the first question is it a good idea for view controllers to know as little as possible about each other? So is it a good idea that a view controller does or does not know about its neighbors in the controller graph? Florian, what do you think?
I would be hesitant to give a general answer on this. I think it's a good concern to have in mind, because I think sometimes we encounter these situations in our code or in other people's code that we have to work on, where we really see, well, these things are so entangled with each other that it's really hard to make any changes, or it's really hard to understand them. And in this case, it might be helpful to start to decoupling them more. And in other cases, it's absolutely no problem if the view controller knows about what's coming next, or what's going to be pushed onto the navigation state next, or if it knows a little bit about embedded child view controllers or something like that. It's very specific to what you do and if this creates problems or not. I think if you are too dogmatic about view controllers, that view controllers shouldn't know anything about any other view controllers, I can imagine situations where this doesn't make your code better either, where you're better off with a bit more of a pragmatic approach. So I would say think about the question if these view controllers should know about each other or not, but I wouldn't decide in the abstract without a specific use case in either direction.
Matt, what do you think?
Yeah, I think Florian's completely right. You need to be pragmatic about these things. If you set a hard rule in application design, oh, I'm never going to let these two things know about each other, then you can end up jumping through a lot of hoops to try and maintain that rule when it would have just made more sense to have, one view controller hand over a piece of information to the next one. It's okay to have knowledge, provided that knowledge occurs along clearly defined lines and it goes through a clean interface. But ultimately, if you want to step around that, the best way is to represent it in a common piece of the model that is shared and have them communicate via the model and have the model decide how to distribute information downwards.
Yeah, I think in our example app, we've also seen both things. Like in the MVVM version, the view controllers hardly know anything about each other, and because we have a coordinator that takes care of it. And in the MVC version, it's also fine, and the view controllers know everything about each other. I do think one really big difference between the two approaches is that in MVC, we need to do integration testing. So we need to bring up the entire tree of view controllers and views and the model, because the view controller cannot really be tested in isolation. And that's, of course, one big difference. If your view controller is decoupled from the rest, then in theory, it's easier to test in isolation. It's still going to be a view controller, so it's still going to be a bit difficult to test. But that's maybe one difference between the two. Yeah, it's another thing to look at. We don't have any more questions. A little bit of housekeeping. So we're still working on the videos and getting them ready. We're still writing. We should be releasing a part of a chapter on networking. We're also still working on copy editing. And I think we're also still working on testing. So there will be also some more releases where we show how to test different architectures. And I think that should be it. Did I forget anything, Florian?
I have one little remark that ties into the last question, because in some of a side note in this question, there was also was asking us to play devil's advocate against some of the alternative architectures. And I just thought about this when you mentioned the videos, because in the videos, we built this mini player feature in all architectures. And I found this interesting also, again, to implement the same feature in all of them, because you notice pretty quickly that you always find things to dislike in any pattern, basically. Some things are very easy in one pattern, and other things are more difficult there, and then the situation is reversed, or it's maybe a higher hurdle to get started, and then things are easier later. But it's all about trade-offs, and I think so. You definitely can play devil's advocate against any of these patterns. But yeah, that's something that is laid out nicely, I think, by the series of videos.
Nice. Okay, then that's it for today. Thank you for watching, and please send more questions. We're not done with the book yet, so that means we're also not done with the Q&A videos yet. And talk to you next week. Bye, Matt. Bye, Florian.
Bye-bye.
Thanks a lot. Bye-bye.